Hello everyone. Welcome to the class. Today, let's talk about file I/O. So one abstraction in your kernel, in your Linux systems, in your Unix systems, there's a one level abstraction called file. So how your kernel use this abstraction to deal with the files and how your process, how your program can actually get access to this resource by using system code related to the file I/O. Let's start. Okay, so this is just shows the idea of your kernel and your user process. The user process, after you run a program, for example, your challenge.c, this program, you got this user process. And inside this user process, you can imagine that it's just like a running program. It's a instance of your running program. And when you have this process, if you want to do something related to, for example, your device, your network, your link, some pipe, this kind of stuff, you need to tell kernel because kernel manage everything like for you. So this is kind of abstraction. If you want to talk to other process, you also need the kernel help you to figure out how to do it. Because kernel is trying to control everything. Okay, so we already covered system code, how to use system code to talk to your kernel to pray for your God. But let's talk about this device today. Okay, so we got a couple different devices inside our systems. We have a network stuff. We use socket to connect the network, and we use pipe to communicate, probably to communicate with other process. We have a mouse or we have screen, this kind of input output we want to connect to this device. And what's the system code we can use it? If you remember, actually we covered a long time ago, there's a library function called fopen, right? Fopen can help us to open a file inside your systems and do some like read and write on these files, right? So if you remember this, actually it can be related to what we will cover today. So if you remember in the lecture, we say, okay, every devices, every this link, internet pipe, all this stuff is packaged as a files in your systems. If you remember this abstraction, you will see, okay, so actually kernel try to treat each of these is a file. Okay, if they are files in your system, which means you can use file library function to access to it, right? But no, file library function like fopen, this kind of function is used to access to a normal regular file, just like a text file or your C file, this kind of like a edit file. It's not used for like open this kind of a device or like a higher level high level of the file system stuff. For example, your network or your I/O stuff. So how can we do it? How can we actually open these files? Actually, this is the goal for today. Today we will cover some system code. The system code can help you to open this file. And actually, it's not so different because the system code of this stuff is called open. So not fopen, it's open. So open is a system code. You can open these particular special files in your process, inside your process. So in this case, you will see if you use standard library stdio, what's the content inside this stdio? Actually, they also use this system code open to implement the library function you need. For example, you want to do a printf, scanf, how to do it? Inside library function, they use open to open the device, the I/O device, mouse, and the screen as an output, mouse or keyboard as your input. They try to open this device as a files inside library function. Then you can use this fancy library function like a printf, scanf to access to these files. Okay, so actually this is the basic idea of how you access to the files. But remember the concept here is that because kernel control everything. And how kernel control this stuff is use file abstraction. So it try to package everything, every device, every network stuff, every link, so like soft link, this kind of concept. It try to package everything into a files. Then you can use file system code to open it, okay, to open this file and read and write, try to communicate with this file. For example, you want to communicate to a remote machine by using the network socket. You just open the socket as a file, you try to write everything into a socket. The operating system, your kernel, will automatically transfer it, like for you to send it to the remote machine. So everything happens in a file. So as a user process, you only need to care about how to open this device, how to send, how to receive the message from this device by using the file IO. Okay, let's see the first basic example. Okay, so we can use files to control the network. We can use file to control pipe. This concept actually you will learn how to use it in a future lecture. But today, let's focus on a very simple one. Just talk about the device. Okay, so if you want to use open your for example, your keyboard, how to do it? Okay, so actually inside each process, to manage these resources, for example, I open a file as a keyboard, how I can communicate with it. So that's a special data structures inside our process. Okay, so this is a file descriptor table. So file descriptor table. So inside this table, you can imagine that it's kind of a lot of pointer, a lot of file descriptor pointer. Each pointer try to point to a device we have. So we try to use this file descriptor table, and inside the table, a lot of pointer. Each pointer can point to particular file stuff. So this is a kind of a concept how to use our the system code to support the connection between the actual files and our software, our user process. And if you know this, you probably should know this. So inside this file descriptor table, this is file descriptor table, file descriptor table. Okay, inside the file descriptor table, the first three pointer is point to the basic stuff. The first pointer point to the standard input, which is your keyboard by default. You can change it, but by default it's a keyboard. The second file descriptor point to your input, your output, which is your screen by default. And the third one, standard arrow, is also a pointer point to the screen. Okay, so you probably can see some weird things here. That's a two pointer point to the same device. Is this okay? Of course it is okay because it's a pointer. You are not going to like store the file into this table. You store the address of this file into this table, right? So they can direct to the same device, of course. So yes, by default we will have these three file descriptor at the beginning, and the first one is standard input, second one is standard output, third one is standard arrow. Then after we start our program, we try to like create more file descriptor. For example, you use fopen, or you just use open the system code to open this file. It will keep using like other file descriptor number to point to the file you want to use. This is the idea about your file descriptor table. So in each user process, you have your own file descriptor table. Okay, so every single lines of this inside this table to store an address of your kind of device. So you can like you can find this device by these pointers. We will go through more details in our lecture. So except open, what else we can do? Open means we want to open a file, right? And of course, we have open, we have a close. Close means we want to close this file descriptor. And it's really good behavior. If you open file, you need to close it. Even though this file is a device, you still need to close it. Between the open and close, there's other stuff we can use, right? So for function library function, we have some, for example, put C get C this function code, and in an open close in the system code we have read and write. So for the detail of open, read, write, and close, please check the slides for more details. But let's see how can we deal with this file descriptor system code, file system code. Okay, so this is an example. We try to implement a special command. It's called CP. Inside of Linux, if you say CP a.txt, b.txt, it will copy everything in your a.txt to b.txt. So actually, this is the program we use in our Linux systems. Okay, so for the CP, first one we have to open. We open two files. So inside the file descriptor, you can see the first one is std in, std out, std error. Then the second, then another one will be this one, fd in, fd out. So it's more like this. Okay, so we define the file descriptor, which should be an integer. We define it equal to the new device be open. So the first device, what device? Actually here, we don't use device because we just open a normal regular file. But you can open a socket by using opens. Yeah, it's okay. Okay, but right now we just deal with the regular file. Okay, the regular file will be, we got the input from your command. So there's two arguments from your command. The first argument will be the file you want to copy from. The second argument will be the file you want to credit. So in this case, we change the mode. The first argument, the first file will be a read only. The second argument will be write only, because we read from the argument one, the first file, then write into the second file. Okay, and we have a really complicated while loop here, but basically you can see the while loop is try to read. I want to read 1024 bytes. Okay, so here's a very important part here, because in a library function you might think, okay, you get C, you just get one character, or you say I want to printf, scanf, like kind of format. I want to scan %d, this kind of format from the file. You can do it, but in the system code, everything is byte by byte. There's no string. There's no other like a special character. It's just like you see one byte, you read the byte. So we want to read 1024 bytes from our file to, we have a buffer. So we have a buffer. We want to store load everything from the first file in 1024 bytes into the buffer. Then we write the buffer. When we write the buffer, how many numbers? So how many number here should be based on how many characters, how many bytes you read. So actually, at read will return a number. The number is called the number indicate how many bytes you actually read from the file. If your file has only like a 500 bytes, then you call read fd in, but buff and 1024, it's only read 500. So you will see 500 here. So based on how many bytes you read, I want to write how many bytes into another file. So this is the idea. Okay, so this is the basic idea to how to use this open, read, and write. Of course, you need to close the file descriptor after you use it. Clear? Okay, so let's look at this example more deeply. So first one, we just try to clean up everything. I just go. Okay, so so you understand this line. Try to get the file, the first file, and this one got to the second file, and the first file for read, the second file for write. And we have a very complicated while loop here, but you know this one means how many bytes is actually read, right? So if I read like 1024 bytes, I will need to write this 1024 bytes into the file, otherwise it's fail. So inside here, there's a very special while loop here. This while loop shows how we actually deal with this writing. Because when you write something into, for example, into your file or your socket or your screen, error might happen. Error might happen. For example, if you want to write 1,000 bytes to your screen, and after you write 500 bytes, some like interrupt just coming, user interrupt, or some like a very like a terrible situation happened, and your kernel decide to deal with this situation first instead of like deal with within this like your user input. So for example, this in this case, you try to uh, write 1,024 bytes, but you might not be able to do it. So this W is less than or equal to CNT. This is you want to write. This is you actually read. You actually wrote. So that's the difference. Okay. So you want to write CNT. You want to write this number of bytes into the file, but you actually can wrote this because some interrupt stuff. Okay, so that's the reason we have the smaller CNT. If the byte we wrote less than CNT means there's some byte I haven't written into the file, the second file. So in this case, what should we do? We do CNT minus equal W and I plus equal W. CNT minus equal W means how many left? How many bytes left? You want to write CNT, but you can only write W. So you need to update your CNT. I write 1024, but I only got 524. So in this case, you need to update your CNT by 1024 minus 524 equal 500. So you have 500 bytes left, and you need to like rewrite it. Okay, and because you have 500 left, so we have this very small one, I plus equal W. We try to update I. We try to update I equal to how many bytes you actually read, right? So like 524. Okay, so I right now is 524. So next time when you go back to a while loop, this one is 524. And based on the address of this 524, if you remember in the array, you can use pointers concept to traverse array, right? So this is the same. You got the address of this element, start from here, and try to write everything start from here. So you already finished. You already finished. If you have a buffer, you already finished these 524 bytes. The only remaining part with 500 is something you want to write into your file. So this is kind of while loop. This while loop is for just kind of avoiding some interrupt, or just make sure every byte you read is actually go into your another file. This is the idea. Okay. This is for today. I hope you understand why we need this this kind of system code to deal with file, because there's an abstraction of our kernel. It's try to like package everything, every device network into a file. So it's extremely important. If we want to use this device, we have to use this open system code, or use read write this system code to communicate with our device. Okay, so but it's not so difficult to actually write this system code, because is just open and open a file descriptor. Then you can use this file descriptor to read and write information or receive information, or and after you done everything, close the file descriptor to make sure the resource you already occupied by your process will be released. Okay, so this is for today, and I hope you enjoy it. And we will talk about a little bit more in our next videos. Okay, so see you next time. File IO is awesome.